Welcome back to Learning Docker. Now in today's tutorial we're going to be looking at load balance stacks using Docker Swarm. So how is load balancing done in a swarm? By default, traffic is routed using the ingress routing mesh and internal load balancing to handle incoming requests. The load balancing default implementation is a round-robin approach using the container DNS records, e.g. app1, app2, app3, then again app1, app2, and so forth. There is a link in the slide which gives you information about the ingress routing mesh, and it goes into a little bit more detail than I plan to in these tutorials, or in this tutorial specifically. So, can we still use bridge networks? With swarms, you can't use a bridge network as it's relative to a single Docker host. A swarm uses multiple hosts, so instead we have to use an overlay network which spreads across multiple hosts. So I'll show you that a little bit more visually now. So this is essentially the sort of swarm that we were looking at last time. So we have the swarm manager, we have node 1, 2, and 3. Now, for example, in node 1, we have our bridge network with 2 web apps and a database. Node 2, same sort of thing. And in node 3, 1 web app and 2 databases. The big kind of thing you'd be asking yourself is, could something in node 1 essentially talk to node 2? And theoretically it can't, because they're running on separate networks, and then you'd need some sort of routing to allow it to route from one to another, maybe like a VPN or some sort of tunnel. You probably could go down that route if you really wanted to, but I wouldn't advise it. Otherwise, it's kind of pointless using a swarm. So essentially what Swarm can allow us to do is use an overlay network, which creates a network across multiple nodes, essentially, or multiple Docker hosts, that will allow us to have interactions between nodes on the containers on different nodes. So let's create a load balance application with this sort of context in mind. Now, I've done a little bit of a pre-setup already. I've already created 2 nodes in a cluster, so that's just one master or one manager and one worker. I renamed node cluster to node worker because it just read a bit easier, because that's essentially what it is. Then I did the same sort of default setup as I did before, where I just spun up the machines. I joined them together as part of a node swarm, a Docker swarm, and then I just made one a master, and then made the other a worker, and then finally just attached it as my local instance. Now, just a side note to this, that I had a problem with Docker version 18.09, and this is why in the Hyper-V setups and also the virtual box setups, I'm specifying an ISO for both of them. And I did this, I updated this in tutorial 8, I think it was, as well, because there was some routing issues I was encountering, or some resolving issues with 18.9. So you do need to run this again. If you do have any Docker swarms set up from a previous tutorial, destroy them. Use Docker machine ls to list your virtual machines, then Docker machine stop, and then finally Docker machine remove. You could obviously just do it via the Hyper-V or whatever, but this is just a cleaner way to do it, and also clean up your Docker machine as well. So once those are done, we can now look at creating our networks. Now I'm going to do this in the same sort of context we did when we were looking at advanced networking within Docker. Now, I know some people have commented that it's not that advanced using just a couple of bridge networks. This time we're going to be using overlay networks, so we're going to be executing the command docker network create with the driver overlay. So as before, it's going to be an overlay network across multiple nodes. We're going to use the same subnets as we did in the previous tutorial. So this one is 172.10.1.0 with a mask of 256, and we're going to just call it tutorial 10 front end. So if I just copy this command, now if you're using PowerShell like myself, you've got to run PowerShell as administrator to interact with a Hyper-V. I don't think you have to for the VirtualBox. I haven't actually tested it on Linux, on Windows with VirtualBox. I've tested it on Linux. I actually had some issues with Linux and VirtualBox as well, where I had to run a lot of the commands as sudo. For some reason, it just could not find the VBox manager. But like I said, there was a couple of little hacks I did for that. If you're interested in those, please leave a comment in a comment below, and I'll try and reply to what I did. But essentially, what we need to do is first create the first front end network. So that's spun up. So if I do docker network ls, we should see. Well, you can see it there already. Our tutorial 10 front-end overland network in the scope of a swarm. So it's very important that it's in the scope of a swarm, because this local scope means your Docker host. Swarm means obviously your Docker Swarm. So if it's not Docker Swarm, your networks won't be able to talk to one another, or your containers won't across networks. So if I do the same thing for the backend network, again, very similar to what we had in tutorial 8, I think I want to say. Actually, I think it was 7. Okay, so we should have the second network set up there. So we've got front end and back end networks. Obviously this time we're using the range 172.10.2 to 172.10.3. So we're going to deploy a stack. Now I'm just going to give you a quick overview of the stack because it's quite important. I've made quite a few changes to this. Now if you cast your mind back just to our last tutorial, in tutorial 9, where we were creating images. Now it's quite important to note that I've actually commented out this here. Now, the reason why I commented this out is for Windows only. This should work fine on Mac and Linux. I have tested on Mac. I have not actually tested on Linux, but I can assume it'd work fine. On the Docker Manager, I was struggling to attach a volume, which was a Windows volume across multiple nodes. Now, this is probably one that is quite complicated because you're sharing a local Windows directory, for instance, across multiple virtual machines of Linux orientation, and yes, it did cause some problems. So what I did was I recreated the image with the files already located within the image, and then pushed them. That's why I'm using version 1.1. I know in my tutorial I did go up to 1.3 previously, but I'm going to leave it in 1.1 because I know it works, and also why I commented out the volumes. So let's just look at what we set up first with the networks. So we're using the networks tutorial 10 front end. It's an external network, which is true because it's already been created. Same for tutorial 10 backend. We're stating first we're going to create a MySQL 8.0 instance. It's using that standard authentication plugin, MySQL native password. Mapping port 3306 to 3306. We're going to be using the network tutorial 10 backend. If you notice, we don't have any IP address management here. The reason I've chose not to do this is because the second service I'm about to show you is a scalable service, and therefore you cannot, if I'm right, you might be able to, feel free to correct me if I'm wrong here, you cannot map a range of IPs that's going to be connected to, short of obviously just defining what IPs are going to be available in the network you're going to be attaching the image to. And then obviously the standard things such as the environment files. Now obviously this is what I just mentioned, so we're going to be using tutorial 10 and front end and back end networks. Pretty much everything the same as tutorial 7, except we're going to be deploying 5 replicas, and we're going to be allocating the limits, resource limits of 0.01 of the overall CPU of the virtual machine that I'm going to be running this on, and 100 meg of memory, and I'm going to restart policy on condition on failure. That's pretty standard for a very basic replica setup. So now what I'm going to do is I'm going to deploy the stack by just simply doing docker stack deploy -c is your compose file. In this sort of syntax you can basically call it anything you want. I've just called it PHP MySQLi Apache, and I'm going to tag it with PHP MySQLi Apache. So now if I run that from the correct container, because I've already attached to the node manager, it should be deploying it on the node manager itself. As you notice, it doesn't create the networks because I'm using external networks. So that should now be up and running. Now there's essentially a couple of tools I can use to check to see if my stack is up and running. It might take a few minutes to spin up, especially with things such as MySQL. So I can do simply docker stack ls to show me my stacks. Now I've got one stack here which is running 2 services in the orchestration of Swarm. I can do docker stack process of the PHP MySQLi Apache. So let's just use the file name instead. So I can see that I have, if I can expand this, can I get this full screen and work? Well, either way, I've got 6 instances running. So it's in the state of, all of them are in the state of running, which is fantastic. It's exactly where we want to be. And as you can see here, when I mentioned with the DNS names, 1, 2, 3, 4, and 5. So when it does round robin, it should hit the www.1 first, then 2, then 3, then 4, then 5, then back to 1, and so forth and so forth. I've not set this up to use any fancy load balancing techniques or whatnot. Another good thing you can do is actually check to see what processes are currently running on what nodes. So when I first was getting into swarms, I did the command docker ps because I was just curious to see what nodes were connected to what. And obviously then I couldn't find any of my processes. But what you can do is simply execute the process on the node itself. So if I do docker dash machine ssh node manager and then just run docker ps, it should tell me what Docker containers are running on that host. So hopefully it should tell me 3 images are running on that host. I don't know if MySQL will be on this one. I assume it will be. So it's running MySQL. Oh no, it isn't. It's not actually running. Oh no, wait. Yes, it is. It's running MySQL. So it's running. It's mapping 3306 to 33060. It's running 2 instances of the web instance, which is 4 and 1. If I do the same thing to the node worker, you should see the other 3 web instances. So that'll be 2, 3, and 5 if I'm correct. Come on, yeah, anytime today. So there we go, 2, 3, and 5. Okay, so that means that the nodes are split evenly across the clusters, across the host. Sorry. Ooh. Now, I can access this if I'm already on the node master. I can access, or I am the node master, I can access it through a localhost. But if I tried to go to localhost port 8080 now, it will not work because I've not actually got a host running on my machine. As you can see, it's an error. So what I need to do is find out the IP of the host, which I can just simply do by docker machine IP and then node manager. Now this is how Swarm Ingress actually works. So if I take the IP address, look at port 8080, I can see MySQL connected successfully. So I'm actually on, I believe, host 1 there. Every time I refresh, I probably should have had something giving you an example, but essentially I should be hitting a different host each time. So if I bring up this, if you're using curl, I don't know if curl works on this. Actually it does. Fantastic, did not know that. I should be able to do something in this style. And it should show me MySQL. Oh no, wait. Let's make sure it's actually in a string. No. Curl does not like that. Let's just find out the IP of the machine again. Let's do it through this. So we've got docker IP. We just simply need to specify the IP in here. So that's going to be 192.168.1.29. Comparison Explorer Engine is not available. Okay, so I have tested this in Linux and Mac, and that works fine. If not, you can test this by simply just going to it in the browser, and obviously you can validate that it works. If you're interested to see what node you're on, you could obviously dump your environment and so forth. But that is basically it for this tutorial. We now have several containers mapped across a swarm. We have a couple of overlay networks which allow the containers to talk across Docker hosts through the swarm, through the overlay network. And if we want to finally just destroy our swarm, we can do docker stack remove php MySQLi, and that will take our swarm down. But obviously it won't take down the networks because we created them outside of the stack. So if I just do docker stack ls, we now have no stacks available. And if I do a docker machine worker just to see what processes are running on, for instance, the node worker, either they'll be stopped or they'll be shutting down. Now, I hope you found this tutorial useful. A couple of comments stating that this might be a bit advanced for some people. It probably is. Like I said, I'll cover some other basic concepts as these tutorials progress. I just want to try and get everything nailed down of the power of Docker. But I hope you found this tutorial useful. If you do, give it a thumbs up. If you have any questions or feedback, leave it in the comment box down below. And if you're interested in any more content I will be providing, hit that subscribe and you'll be notified when I release my next video. But until next time, I hope you have fun with Docker, and I'll see you around.